3D printing in mechanical engineering. In the dynamic world of mechanical engineering, 3D printing has emerged as a transformative technology, revolutionizing the way products are designed, prototyped, and manufactured. This innovative process offers engineers unprecedented design flexibility, rapid iteration, and the ability to create customized parts and components with unparalleled precision and efficiency. Introduction to 3D printing technology. First, additive manufacturing. 3D printing, also known as additive manufacturing, is a process that builds objects by layering materials, typically plastics, metals, or resins, to create a three-dimensional structure based on digital 3D models. Second, diverse printing techniques. Various 3D printing technologies such as fused deposition modeling (FDM), stereolithography (SLA), and selective laser sintering (SLS), each with their own unique capabilities and applications, cater to the diverse needs of mechanical engineering. Third, rapid prototyping. 3D printing enables rapid prototyping, allowing engineers to quickly create physical models, test designs, and iterate on ideas, significantly reducing the time and the cost of the product development cycle. Benefit of 3D printing in mechanical engineering. Design flexibility. 3D printing liberates mechanical engineers from the constraint of traditional manufacturing methods, allowing them to create complex organic shapes and intricate geometries that would be difficult or impossible to produce using conventional techniques. Cost optimization. By eliminating the need for specialized tooling, and reducing material waste. Then accelerated innovation, the ability to rapidly iterate and test design, coupled with the freedom to explore novel concepts, enable mechanical engineers to drive innovation forward at a faster pace, ultimately leading to more advanced and efficient products.